Dear guests, good afternoon. So you all signed in for a presentation in turbo mode. Now then, simply give a warm welcome to Jeremy Vyska.
Good afternoon, everybody. So I have the dubious pleasure of being the last session before everyone scatters to the wind. That's the bad news. The good news is I'm not the last session before everyone gets to go and enjoy beer, so I'm not slowing you down to that. For those of you who don't know me, just a real quick summary. I've been in the industry now for 25 years. I've written some books about Business Central. I've been an MVP for a few years. Do a lot of free and open source utilities for the community, QR code to link to a variety of them. For example, I have the weekly digest that sends a blog post summary of all the blog posts in the community, so you can just keep up with things a little bit. So, what this talk is about. I wanted to do something about AL code, because we kind of haven't had a lot of that in the past couple days. I don't know how many of you have noticed and gone, but I wanted to talk about the challenge of parallelism and how do we deal with some of the things that are going through that and the performance impact of doing these things. What this is not a talk about is explaining how job queue management works. Like, what are all the features, the scheduling, restarting things. AJ Kaufman has done a great talk about job queues that explains the engineering of how job queues is the UI that sits on top of the task scheduler and how all those things behave together. That's a phenomenal talk. If you haven't seen it, hopefully you can find that and it will be made available. But this also, for those of you who need the break, this isn't a session on Copilot. Okay. I sense the AI fatigue. All right. So I'm going to start this out a little bit oddly. It's why did I submit this talk? And there's a little bit of a story, and I hope you'll bear with me. It's, I think, a story that a lot of you can relate to. I started with a company earlier this year that does business-to-business and business-to-consumer website integration stuff. And when you're doing those sort of things, you have a limited number of ways that you can bring data into Business Central. APIs, flat files, all that sort of stuff. The job queue is our only scheduled userless operation to process things. So we had a customer that had a very, very busy November last year. True, funny sort of story. I'm a transplant to Sweden. And during November last year, they had Black Friday sales. Like many people have adopted from the US around the world, they had Black Friday sales. But one of the things I love about Swedes is that they take a concept and they kind of make it their own. I think the keynote showed there are 17 of us here, so maybe some of you are in here. They tend to make the story their own, so my favorite thing I will see in November is Black Friday sales all month. A little bit confusing there. So our Black Friday for our customers could be a day long, it could be a weekend long, it could be a week long, it could be a month long. And we had a customer that was processing 3,000 orders an hour in their environment through imports from an external system, coming from 10 different shops all over the different countries that they do business in. All of that was flowing into Business Central in a central queue processing table for a job queue to pick up and process through. And what we were discovering is that the jobs that we had defined, they work well. Our customers find them very, very reliable. But all systems scale to a point. There is always a point where the demand and the load is more than the system was designed for and can handle. We had inadvertently discovered that limit. Our customer, that when those orders came in, the orders would be released. There would be a bunch of operations that would happen to those orders. We would create customers. We'd create ship-tos. When they were released, they were dispatched back out of the system to a third-party logistics company to fulfill that order. So a huge amount of things would happen when that order JSON came in. I'm just curious, since we've got these little guys this year and I want to make use of them a little bit, are there people in the room who have had to solve similar technical challenges in their nav and BC environment? So that's a pretty big constellation in this room. For the folks at home, out of the several hundred people, we had at least 100 twinkling lights. So the challenge that we ran into is the customer said, this was a low year for us. And I was a little bit set aback because 3,000 orders an hour is kind of a big deal for a Business Central cloud, I thought. And they said, if you cannot prove that this system will be able to keep up with growth over the next 5 years at the rate we've been growing, here's our projected number of orders per hour during Black Week we want you to meet and prove. Because we had a long-standing customer relationship, they trusted us, but this was something existential. If the system couldn't keep up, what ended up happening during some of those Black Week days, and we fixed it very quickly, is that the orders processing coming in were so slow that the orders going back out to the logistics system, their warehouse operation team was at a standstill. They had thousands of orders coming in all the time, and the warehouse team was just twiddling their thumbs. Very, very expensive scenario to have in a production environment. So we had good trust. They believed that we could solve it, but they were worried, and it was a valid worry. So they gave me 2 weeks and said, whatever you want to do, it's an AppSource app, don't do breaking changes, but whatever you want to do, try to solve this problem. You're an MVP, you've been to lots of conferences for the past few years, you think of creative things, throw everything. We called it spaghetti brainstorming. We took a pot of ideas, threw it at the wall, and saw what noodles stuck. We had a lot of those. And what I ended up with was a set of process improvements to the job queue that anywhere from 40 to 93% faster operation through our sample data set of 20,000 orders. I didn't believe it. I spent 3 days running more scenarios, creating customers, adding more lines, adding more validations. We had, like many of you probably have experienced, we had third-party apps from AppSource. Our customer creation process, it was running through a credit check, so it would also call APIs while it was doing all of these operations. There were performance problems there. We helped them solve that with telemetry and all that sort of thing. So we needed to prove quantifiably, and the data was exceptional. It was remarkable. And I believe the quote is something along the lines of, extraordinary claims requires extraordinary proof. So we had to prove for our customer. I came up with this pattern, and later that week, the session submission for Tech Days was closing. And I said, is there any chance I can share this with the community and see if other people can try this out? I want this to be a thought experiment that you can take home and explore. I don't know if this is a good pattern yet. Our customers, our biggest performing customers, are all live on this and have been for months. We have not had problems. I want to hear back from you. I'm not hard to find, so if you try some of the things you learn here today and it works, please give me that feedback. If you found faults in the ideas, please give me that feedback. I called a couple of my MVP friends to say, is this pattern safe? And the answer was, put it out there. See this is a great community. They do all sorts of clever things. Let's find out what we can solve. So our challenge scenario that we're going to dive into today is that we need to do high volume operations. We have data validation operations that need to happen. We need to process a lot of data. We need to create documents, because the number one question I got in the app ahead of this session was about locking. Whether, it phrased in different ways, but the question I was getting mostly is about locking. And we need to have some buffer tables. It needs to be a mission critical process, and we need it to not be painfully slow. So today, we're going to demo through a web shop flow that mimics a common scenario. There were about 100 twinkling lights, so I think a lot of people have had an experience like this. So our scenario is that we're going to do a validation step on an ordered JSON that's coming in, which would do some quality checking, make sure that the values in the JSON are the right data type and all that sort of thing. We can simulate that. You guys know a lot about it. The big heavy thing that needs to happen is the process, the business logic. This is where the locking nightmares come into play for a lot of people. And then we're going to mock up doing some emitting to third-party systems and email notifications. Most of you have done something like this. We're not going to create a whole framework for these sort of things. And apologies to Vyska, who's not here. I'm using it as mocking. It's not an interface enum style mocking. We're just doing a simple pretendsies. So our baseline sample that we're going to work with today, and we'll I'm so not Copilot in this session that we're not even on cloud. This is just a local Docker. So we've got this Turbo app demo. And what we've done is in here, we've got our initial baseline of customers, some addresses, some vendors, some items. And in our scenario, the customer, they do fulfillment from multiple locations, but they dispatch from a central warehouse. So when we write up a sales order, it might be in stock in our main warehouse, or we may need to transfer it to our central location for dispatch, or we may need to buy more. So our role center reflects some of those different data operations that we may do as we work through this, just to explain point by point what's on here. And then we've got that web queue table that has the different states that we're going through. When it first comes in, it's going to be a new web order. Then we're going to do our JSON validation, make sure the data types are all fine and that sort of thing. And then going from validated, that's when we do the heavy job. We're going to process that data, and that's going to create customers, create ship-tos, create sales orders, create purchase orders, create transfer orders. Does anyone think that that's a lot of locking for one step? It is. And it's a very common pattern because that pattern is kind of an atomic unit. They go together. And then we'll do our simulation of we're emitting that to a web order, and then we get the email that goes out to the customer. So that's our scenario that we're going to work with today. And nice and simple, we're going to generate our first batch of web orders. And this will give us a set of web orders in our queue table. And if we take a look at this, it's a pretty standard JSON of a web shop order. Nothing too fancy. We have, the web order number, a buyer, a ship to, some lines on here with some quantities. We're not letting the customer set their own price, so those are all zeros. This also reflects a challenge that we had in our own environment, which we're going to hit on a little bit later. Wonderful world of app source and breaking changes. Someone originally designed this product when it was on-prem, so guess what? The primary key was a GUID. That was real fun. It's actually a composed primary key, so I wanted to simulate that in our environment here to talk about how we do some things. So that's the idea of this web queue, and then it's going to march through all these individual steps. So for running these, because I don't want to wait 1 minute for each cycle for the job queue to take over, we do not have enough beer for that to just sit here and wait for the job queue. So we're going to use the performance toolkit. I hope most of you have at least tried this out. But this allows us to run processes in multiple sessions. Our first run through that we're going to do mimics the way a lot of BC and Nav developers would write a job queue code unit. Everything happens in one big process. It's kicked off by maybe one individual code unit. There might be helper libraries that do all the individual pieces, but effectively, it's one job. So for that configuration, we are going to run that in foreground, which also means that we're going to get the ability to have GUI things happening and whatnot. And we're only going to run one session. And I'll set this for 3 minutes because I think that's on average about the processing time of this. So real simple. We'll kick that off so that way it's ticking along. And we can see it's validating orders. It's going to give us some information about the process as we're running through things. And if we refresh on our role center, we can see that the job is ticking along through the different steps. And we're now, after a few seconds, we're now in the process where orders are starting to create. And we can see that we're in a position here because the sequence of this design is that it's validating, it's then releasing and doing all the process operations, and then it's emitting. This means that we've already just created in the past few seconds 200 sales orders that haven't gone to our logistics company. They're still twiddling their thumbs. So one of the things that some clever people will do is they will say, okay, well, how about we take a web order and we push it through all of the stages one document at a time instead. So at least that way we're getting through all the operations. And that's not too bad of an idea. That's one way to potentially solve this. I didn't mention it, but I wanted to call this out. This little error web orders queue on the side here, if any of the operations go wrong due to a deadlock or any errors happen whatsoever, they will show up in this queue. Any errors that happen will pop into here. So if we get locking issues in any of our demo today, we'll see that tick up from 0. So that's pretty basic. Most of the folks in here are already envisioning in their head kind of how the process of this is working. I left myself some notes in the beginning of this object. Quick aside, this entire application, it's in GitHub. It's on my GitHub profile. It's pinned BC TechDays 2025 Turbo app. So you can absolutely review the code that's on this. It mostly is OK code, and we'll talk about why later. Don't run it in production. It has a ton of data generators in here. But this is the basic idea of that it would on run. We are going to validate our orders. We're going to process them, emit them, send notification. All the standard stuff. And each of these code units, with the exception of lots of logging that I use for diagnostics and timings and all that sort of thing, effectively, we're looking for any new status web queue jobs. And then with some updates, if it's GUI allowed, we're going to do our lovely code unit.run on that. And if it fails, we'll tip it over to error. Quick check of the room, because we have varying degrees of tech people and knowledge in the room. How many people in here are unfamiliar with, feel free to light up, unfamiliar with code unit.run handling? We do have a few. OK. Super quick aside. Code unit.run, if you catch the result of it, runs it as a discrete separate session. It's a whole separate write transaction. If you are on-prem, it's not allowed by default. You'll need to turn that on. On cloud, it is allowed. What this will do is if any errors happen during the execution of this code unit, this will return false, and you're able to access the last error text as well as the last call stack and all that sort of thing. So this is that design principle that Henrik Helgeson talks a lot about, which is give your users a chance. This is give your code a chance. How do you catch errors? But you cannot be in the middle of a write transaction when you start a code unit.run. So we have our lovely commit here happen before that. If you don't do that, I discovered this the fun way. In Docker, at least, you just get an error. It doesn't tell you what. You can export the event log. It still doesn't tell you what. I don't know what version that stopped working. It used to tell you that write transactions weren't allowed during a try, and now it just crashes. But the general principle of all of these procedures is the same. It's basically just on a status and looping through and doing operations. Now, the savvier people in the crowd would be shouting at me at this point, that's an enum, and you're basically just running loops of things. You could absolutely do this as an interface on the enum and just call the interface. Yes, I could. The point of this solution demo was to show even back in Nav, this worked. I used to write code along these lines when we had the NOS. No screams of terror when I said the word NOS. That's good. For those of you who don't know, that was the on-prem job queue before there was job queue. Nightmare. It got much better when we went cloud. So that basic operation has gone through, and we now see our lovely process has completed. And of course, we only ran one code unit, and we ran it in our session. So of course, there's no deadlocks. Why would there be? In our operation, every single step for every single document, we're calling a commit. So there's no potential for locking. We're releasing those locks very quickly. So okay, that's not too bad. Just to help visualize that a little bit, let's grab let's grab a flowchart here, and we're in fact going to look at that as a Gantt. So we can see that at beginning to end, it took about 10 seconds or so to move through the validating step, and then we moved through some processing, and we went through fulfilling and emailing. So very waterfall methodology on our web queue. Could I have done this in Telemetry with Azure Data Explorer, Power BI, all those sort of things? Of course I could. I wanted an offline capable version of this solution. So this is just displaying exactly what we expected. We went through the web queue. It created customers and ship-tos. So if we take a look at the operation, just to validate that we're doing all these things, we created 500 new customers. We created all sorts of ship-tos for them. To be able to fulfill those orders, we created a lot of related documents. This is going to be important for the following flows where we're running through the parallel steps. So we cruise through each of those different operational steps. And that was what I call the basic standard loop of forever. Some of you have had the pain experience that I've done where it's still working on the first batch of 2,000 orders and you're just waiting for it to get through. So the big problem here is that all orders for a given stage have to be handled for the orders to move through to the next stage. You might be able to do a per document flow, maybe. That might get you through some things. So let's move to the good stuff, right? The good stuff is parallel operators. Now, this one is where there be dragons. The number one question I got was about locking. And I also got some questions about what's the division of labor, what jobs are doing what, and can we do anything to think about stages. So the key to the parallel operators that we implemented in our solution, and we're going to be going through today, is we're going to be doing batches at a time. We don't want to just say, give me all of the new web orders and I'll run through all of them. So not only are we doing parallel operations, we're doing batch operations. So that already is going to start to help. The other key things about this methodology that I'm using here is that those batches are going to be finite, and all of the things that we do to each of those entries in that batch is a very atomic transaction. So talking about this as a new and experimental pattern, if you're trying to do some sort of posting routine that's going to post 10,000 journal lines, this might not be the pattern. If the whole batch is supposed to succeed or fail together, this might not be your solve. But here we have a pile of discrete operations. They're very atomic. So let's dive into what does that look like, because I think this is the part that we all want. So first of all, let's scooch some things out of the way so we can look at our logic here. So in our on run, we're going to take a tour through some of the functions that I'm working with here in a little bit out of order from the way that the function explains it. First of all, we need to locate all the entries that are relevant to this run. And I'm going to locate all the new entries that I might want. I'm going to locate the validated entries, the release, fulfilled, all those different statuses. I'm going to call these little sub-procedures. Again, could be clever with some enums interfaces. Wanted to keep this simple. So first of all, before we locate any entries, we're going to check against an operational limit. How big do I want the batches to be? If the operations that we're going to do is larger than the batch, bail out. Stop. Like, let's let this job queue complete. We don't want a job queue that runs for 8 hours. We want these to be fast. So then it will loop through the new status entries. And again, we check to make sure we're well within the limits and all that. And then if we find an entry, we'll add it to this object. On this object is simply enough. Because my demo primary key is just a GUID, stick it in a list. .NET lists, because this is effectively under the hood just a .NET list, they're very, very fast. I was addicted in the nav world and for a very long time to temporary tables. Anyone else also a temporary table addict? Definitely a few hands in the room. I've moved a lot to using lists and dictionaries because top secret engine tip under the hood, temporary tables tend to get rendered as .NET dictionaries and lists. So skip the middleman if you're dealing with simple things. So this list of goods will be the operations that we're working through. And we increment the operations to do. Now that's nice and all, but that doesn't get us our parallelism. We've now invented the batching system. So the next thing that is relevant to our being able to run in parallel is this little lovely beast. Emit the claimed operations to team. And what this will do is it's going to scoop up all of the operations in each of our lists of goods, and we're going to stuff that into a JSON object. No big deal. We've got lovely JSON handling, and it keeps getting stronger, so why not? And then, for funsies, we'll just write this to a record, my control table. This little control table is just going to be a code and a claim timestamp. I'll keep track of what session so we can clean up after the fact. There's some logic behind that. And then we just stuff that job in a JSON in a blob. Nice and simple. In early iterations on this, I did what you normally would do as a nav developer. If I was going to say, I want to process those 100 orders, I will claim them, I might set my filters and then modify all claimed or claimed by session ID. That's 100 writes. That's a lot of locking on that queue table. So we moved it off to a separate table, write once. Read many, write once. So in our flow here of the operator control, we just write that out to that. Then in our next step of operations, we'll execute all of the operations. But let's swing back to that locate all entries. There was a function call I skipped over, gather all the claimed entries. What this does, as you might imagine, is we can loop through that control table that isn't the current one we're running, and we can rehydrate that JSON object that's stored in our blob and bring that together into a new list. So we create a new list of goods of everything that's already claimed. Nice and simple. So in my case scenario that I'm going to show shortly, we have 5 different processes running at the same time. Someone was a wise guy and suggested in my demo, it's Friday the 13th and the 13th Tech Days. Why not 13 background jobs? Okay. So what will happen is when that 5th version of this operator starts up, is this list, based on my operational limit target, say it's 100, this list will contain 400 goods that are already claimed. And that means that when I'm locating my entries here, I can check, because contains is an option, I can look in this list of goods to go, is this one already claimed by someone else? If it is, don't do anything with it. Just skip it. So this got me around one of my other fundamental problems of, if you're trying to do batching-based logic, could you do like entry number 1 to 99, 100 to 199? I couldn't. I had a composed primary key that had a GUID. So, and again, no breaking changes. Okay, fine, no breaking changes. So this creates the list that effectively gives us our operational list of what we need to operate on. And then finally, when we call our execute operations, we have our GUIDs of which operations to do. And they're just in these lovely little lists. So execute all operations, does any new, does any validated, does any release, does any fulfilled. And we just do a lovely little for each loop through it, and we go get from the web queue table. And just like we saw in the first operation, we're doing the commit and code unit.run, log if things go wrong and all that fun stuff, commit afterwards. It's very heavy on the commits, so be very, very thoughtful when you're using this pattern. Make sure that if you're going to need to roll back something in case of failure, that it's wrapped up inside of the code unit.run. So like sales header, if the line creation fails, you want the header to roll back. So the header and line need to be created within the same commit stack. And that's the core idea of getting both batching and parallel workflow running at the same time. So we're going to reset our data. And I don't know, for those who have been to some of my talks before or seen them on the Tech Days YouTube channel, I hope everyone here already knows about the YouTube channel for Tech Days. One of the things I've always spoken to is if you're doing demo, if you're doing training, give yourself something to be able to run things over and over again. You never know how many times you're going to need to run things. So very simply, this resets my app back to the starting point. This removes all of the data that we just created, recreates the baseline of all of our customers, our items, and we're all clean to go. Nice and tidy, ready to run things again. Hopefully, folks are doing stuff like that. It's really helpful when you're doing user testing. The demo here for our operator steps is basically now we're going to say, for this operator, we're going to run 5 sessions at the same time. Because it's not running in the foreground, this effectively mimics the idea of 5 different job queues running at the same time. And then just for variation's sake, you can set some delay and set it to be randomized. So they won't start all at the same time. You can have that mimic process. Again, I didn't want to wait for the job queue to tick along for all of our different steps. So if we kick this off, this is now running in the background. And if we come to our role center, we should, within a little bit of time here, we should see some operations ticking by. And of course, I don't. The demo gods have not been kind. I don't know if anyone's noticed that at Tech Days this week. The demo gods have been a little mean. We have, what's up? We are getting a lot more locking than expected. So what's happening? Cool. Excellent. Someone called out the correct thing. I was clicking too quickly, and it's sitting there processing an empty queue. Thank you. Exactly so. So generate the web orders, which only takes a second. We're just piling up a bunch of JSON. So we'll kick that off again. And now we should see. We can see that the batches are ticking along, and we're already starting to see the validations happening, and we're also starting to get some orders release. As each of those are going through, we're going to see that it's not going to wait for all the validations to be done. We're going to do different steps at different points in time. So this is, at the moment, being controlled by a setup table that I have for just saying the operation limit. I want you to do batches of 25 at a time. So nice and easy. It's cruising through and creating 25 at a time. And that, for about 500 orders, only takes 3 minutes or so. So that goes pretty quick. And one of the nice things is because these are running as separate operational jobs, in job queue, we have the lovely parameter string that we can potentially pass into the operation, which means that we can do different operation types. So if it's a big deal for me that I want to, no matter how slow the order ingestion is going, I want to always have something ticking over doing the emit, we can do an if wrapper around that execute job, and we can pass that parameter string into the job and say, I want you, this particular job instance, to be cruising along and only doing the emit operation. I did get the question of, if you're creating all of these background jobs, what are the limits? And this is the nice, easy answer on that. The scheduled task is based on the number of users that your environment is licensed for. It's not always phrased super awesome. The more users you have in your environment, the more tasks you can run in it. And it's basically 5 per user. This does not mean the user who clicked the start the job queue button. So if you have 20 users in your environment, you have 500 potential background tasks going. So they're pretty generous. It used to be much smaller. I did chat with the Microsoft people about the fact that I'm teaching everyone how to run as many of these as you possibly want and how much that's going to hurt them. And they said it's fine. Because this is simulating a user volume, the load of the extra jobs running is That's why they gave us this. So this allows you to make the most of your environment, and you can scale that up and down. I also got the question from someone in chatting about this. I'm doing a demonstration where it's a single list, a primary key value of just one data type. But my real production environment, we don't have just a simple GUID or entry number as our primary key for that web entry table, unfortunately. So the way we handled that one to be able to make use of lists in this environment is we simply converted all of the primary key fields into string. So we had a list of text. No big deal. When you do your go get later, you're basically saying, I want to go get this entry, and that's coming from your list. So all you would need to do in this environment is you would split the this entry string into its components. So you would do your lovely little split function, whether it be dashes, whatever have you. No big deal. As long as it can be stuffed into some sort of list. I said it was going to be a Copilot free session. Sorry. I'll disable it. My bad. We'll disable that. Get out of here. So you can absolutely do this with compose keys. That's no big deal. So if you're doing a job queue that runs on sales header, purchase header, just compose the key of string. For options and enums, you can use the value or text, as long as it makes sense to you to be able to do a get on the source record to begin with. And then we also ran into the issue of some of our customers wanted to know how frequently the job queues should run. Because sometimes, if we are doing these little batches, there might be the job queue runs on a batch of 100 orders, and then it's idle for 4 minutes. Because it's running every 5 minutes, it only took 1 minute. Just curious, does anyone have that sort of problem where their job queue's trying to figure out how the heck to get the timings on them? Yeah. Yeah, me too. So there's not a great answer on that one. I will say that, having seen AJ's talk about things, I set the minutes between runs down to the lowest value I think makes sense if I need it to actually pause or not. Because if it takes 15 minutes to run and it's 1 minute between runs, it'll run for 15 minutes and wait 1 minute. It's not running every 5 minutes. It's from the end of a run, wait 5. So he has some really great feedback to Microsoft in his sessions on we can improve some of the tooltips and captions on the job queue a little bit to explain better how they work. So we wanted to, for our customer, be able to do something a little bit more exciting and make it a little bit more thoughtful about how we're doing some of these different batching operations. So right now, in my environment, which we haven't checked on it, but check that out, 0. I had 0 deadlocks, and I was running 5 different job queues at the same time on those batches. And process-wise, if we wanted to sneak a peek at that, we can see that nice and easy, because I'm a big fan of visuals. Everyone, big fan of visuals? I like visuals. Yeah. We have all these different operators running in the different modes, and we can see that it went through some validation cycles before it kicked off the much longer processing job. And we can see that the processing jobs are what's taking the time. So with a little bit of logging, not unlike telemetry, I'm just keeping it in product because I wanted an in-product answer. We can see that the bulk of things is the processing, but overall, our start and end times, you can see it's diminishing. That's pretty nice. I like that. But we're still where I wanted us to be, 0 errors. There was not a single deadlock in that entire run of things. So that's pretty cool. We'll go ahead and reset the data on that, and I'll remember to create the orders this time. What we added to our setup before was a global operations limit. So our version 2 of our processing said we're going to run 25 in our batches. Well, I want to be a little bit more clever with that. Some of you are very clever people in this room and may have even written things like this. I'm probably not the first. I generally say I'm never the first guy to have an idea. I might be the first guy to get up and talk about it. what I added to our operator control that we saw earlier, where we could inspect the claims and all that sort of thing, is give them a target number of operations and give them some nice guardrails, minimums and maximums. And now, one of our lovely things that we can do in our operations is we take our operator 2, the way that things were working before, where we were batching up and we were doing all those locations and all that fun stuff. We instead, when we grab an operator control record, we'll grab what is our operation limit. This is the number of target operations that we want to run. Well, all that did was move my setup field, right? Yeah, well, fair enough. But down here, if we're using dynamic scaling for this operator, maybe you might not want that for one of them for different priorities, whatever have you. We're going to just do a adjusting routine that says, okay, let's look at the total operations that this cycle ran through. If we didn't do anything, we're not going to adjust anything. But let's also calculate the runtime. And then what we would do, and unfortunately because I'm in a demo environment where I'm not running the job queue, what I would do in my product, in my solution, is I go out to the job queue and I look at the runtime between runs in minutes. So for example, 5 minutes between runs, I would say, okay, if the runtime is less than my job queue minutes, increase the target operations by 10%. That's all. Nothing too fancy. And because it's an integer, we'll round it. And if the operation took longer than the runtimes, it took 6 minutes to do that 5-minute job, decrease it by 10%. And we put some nice little safety rails around, minimums and maximums. So from a functional flow on that, let's grab our 500 orders, and I think we'll be brave. We'll bump that up to 1,000. Since I already had a nice demo hiccup on demo 2, let's give myself one for demo 3. And we'll increase that runtime a little bit. And same situation, we're going to run 5 sessions of this, and we'll kick that off. Because those are all running like job queues as background jobs, there's no UI to let me know where things are, but we can see that things are already ticking along on the validation process. And now we've got orders getting created. So that allows me to keep an eye, because I've got the control list here, that allows me to keep an eye on the operations. And you can see that dynamically, these are already starting to crank up. We can see that the run times, it's keeping an eye on those things just because I like diagnostics. And I love telemetry. But I also like in-app information. I need it right in front of me if it's relevant to what's right in front of me. So you can see that this is just going to go, okay, well, I'm able to pick up 43 next time. And this is just going to dynamically grow the list. And if something happens, like start a business day, a CFO posts his budget that's 150,000 line journal, then you can go ahead and scale that back down the next time it runs. No big deal. So those are just marching along in the background, and we've got our lovely dynamic scaling. So we'll take a look at the results of that in a moment, because I did bump it up to 1,000 because I want to force a deadlock to happen. I don't know if I can, actually. So the critical considerations to this pattern is that it needs to be tiny atomic transactions. It absolutely must be those sort of things. One of the things I was looking at is, for example, are there places in the base product that we could make use of this pattern? And an example we were balling around in the office was adjusting cost on items. For example, many people schedule a job to adjust costs. Well, we can't necessarily do adjustments for an individual item at an atomic level, but that one item run, sure, we could do that. So that would make sense. Adjust cost for one item at a time, parallel that up. We'll see how that goes in a couple of our customer environments. We're trying it in a PTE right now. Error handling is vital because you are introducing a mechanism where you have a much higher probability of locking the records that you're working with. And just as an aside, because lots of people were asking locking-related questions, one of the things, I think it was 2 years ago, Mads did a session here at Tech Days that was talking about tri-state locking and when the different operations would lock things. If you are modifying records and then you go read another record, that potentially locks more tables than you think it does. So be a little bit careful about when you're starting a transaction and then going and getting data. So when I'm trying to avoid locking issues, I try to front load as much of the read operations before my transaction starts. Some of our customers where they've needed to avoid these locking problems, similar to this job queue functionality, if I needed data, I would run queries and load that up into buffers. I'd load that up into lists or dictionaries. And only when I've got all the data I could possibly gather together, then start the right transaction and move on to committing. So think very hard about what you can do to minimize your locking footprint, and that'll help things out. One of the things I did not implement on this that is in our product is, of course, when something is coming in from the web shop and it runs into a locking issue, I don't want the user to just have to go to a screen and click retry. That would be bonkers. So I would normally, in our workflow, and apologies to anyone who does have that and just felt like bonkers, no. I wanted the deadlocks to show up here. So one of the things I would do is I would consider to be a record on this web entries table that says number of times to retry, and have the job pick those back up, and potentially have a self-cleaning routine. And we can see that with 5 parallel operations against the 1,000 records, I'm still at 0 deadlocks. That's pretty good, right? I think that's pretty good. Okay, so I hope, since I did get a bunch of questions in Whova about locking, do folks mostly feel like that kind of answered how do I address some of those locking considerations? Okay, there were a couple of hands from that. I did get a separate question from Whova that I wanted to address that even though this talk is not about managing job queues, I got the question of if you're creating 12 different job queues for one process in BC, how do you manage this? How do you help customers actually react when things fail? Well, first of all, do your darndest to catch errors. The more you can prevent a job queue from erroring conditions, great. There's a limit. There's only so much you can do. My favorite example with web shop orders is when someone decides to block a dimension. Well, that shouldn't cause any problems. Block. All of our web order imports suddenly just stop. So there's only so much you can do, but do as much as you can with that. And then I hope that most of you have watched Waldo's sessions in the past about telemetry data to understand how to read and evaluate environmental telemetry. There is a telemetry event for if a job queue has failed and it's no longer going to try to restart. That's the one you want to watch for. And I was a little bit surprised. I've talked to some people in my organization and in the industry about this. Telemetry is something that's not just for Power BI to consume. Telemetry can be consumed by all sorts of different things. So what we have in our organization is we have a logic app that consumes the job queue has failed and someone needs to deal with this, and send a Teams notification to our support team or to our customer in an email. But we only do that on that failed status when it's failed in a way that it's not going to restart. Because if it's just erroring job queues, it's just noise. No IT manager wants to sit there and be like, I got to restart the job queue. So when it comes to managing lots and lots of job queues, make them as resilient as you possibly can. Don't fail if you can avoid failing. One of the things that I do in our organization, if data can't go through because of a setup issue, that goes to a separate table. It gets moved over into a malformed data situation table, and then the job queues can keep processing. And we can address that malformed data in a separate way. And the thing I would recommend because I don't remember the telemetry event, so I'm just going to bring it up. In telemetry, quick check, has anyone not seen this before? Okay. I do get a little surprised sometimes here and there, but every day you learn new stuff. So if you didn't know this existed, centralq.ai, I tell everyone in almost every conversation about it. The CentralQ AI is built by Dmitry Katzin. It is built off of not only Learn content, but it's also built off of books that I've submitted to him for that. It's built off of blog content from around the community. And the crazy mad scientist that is Dmitry managed to also go out to all of the MVP's YouTube channels, Areopa's YouTube channels, TechDays, and get transcripts. So when you search this, it will actually take you to the YouTube video timestamp of when someone mentioned it. So in telemetry, what is the job failed not restarting event? We'll see if it recognizes it as a BC question, because he did do proper, like, don't harm. And I'm quietly sneaking this in here. This is LLM stuff, but it's not Copilot. All right, so we've got some information. I don't trust LLMs, so let's see if that's right. We'll take a look here. And it was suggesting that I want HE7, and let's check that out, see if it's right. Job queue errored. That's not bad. I believe there's actually a separate one for errored, and it's not going to restart that's relatively new. So it may not have picked that one up yet. But that's the general idea of CentralQ, is that it will list for you all of the different sources that it came from, and this includes blogs from people. So for example, here's Christoph's blog. So strongly recommend use this. And to answer the management question I got, here's your answer on Christoph's blog. How do you restart all your job queues? Well, use some Power Platform. There's API calls you can make that just restarts. No problem. He gives you the step-by-step. How? How do you do that? So it's not scary. And that was all I got of. I was just trying to figure out what to do. I didn't even know what the answer was. And now I've got my answer. So wanted to raise that up because that sounded like it was a real pain point for a lot of people of how do I manage the job queues. This is the lovely answer to that. Make a little bit of a toolkit for yourself to get them restarted. But do what you can to make them resilient. I suspect most of you who have had problem with job queues and managing of them, it tends not to be your code that's the problem, right? It's never your code. That's my experience as well. So a small thing. I did say it was not a Copilot session. I wanted to mention there was an asterisk on that one. I actually set out for myself a little bit of a challenge. Some of you may remember 4 or 5 years ago, I started streaming about BC, and that's ended up being the road to MVP speaker and all those sort of things. 5 years ago, in the summer, I was just a nav developer. I was in a small shop. There was all nav development. We were stuck in the on-prem old ways. We were the quintessential dinosaur situation. I took a couple weeks off and said, I need to learn extensions. Well, that's a really great way to challenge yourself, to develop. So coming to this talk, I said I wanted to challenge myself. I wanted to move forward. Every single line of code in this entire solution, all of it, is Copilot generated. I did not write any of this code whatsoever. All of the tables, all of the event subscribing, every single one of these things. So I apologize, but my very first slide, I lied to you. It's a 100% Copilot situation. So there were some interesting things along the way. I wanted to share that with you because I wanted to challenge you. It's very easy to do exactly what I've been doing. We're peers. We're the same. I'm on this side. I've been doing the same thing. I'm typing in VS Code. I've got GitHub Copilot installed, and occasionally I can hit Tab, and it understood, and I need a brace. Well, that really didn't feel like that was a revolutionary change. Of course it didn't. Hopefully, Some of you saw AJ and Dimitri's session yesterday talking about vibe coding and all that sort of thing. It felt very bad vibe coding. But I absolutely had all of the code generated by agents. And one of my favorite ones that I challenged myself to learn early on was because I like doing demos from role centers, but the demo role centers don't help me with PTEs. They don't help me with products. Who here likes making role centers? It's not fun code. It's not fun to write that. So I instead gave a set of instructions, and I told it to create the scaffolding for a role center for me. Go ahead and add customers and items and vendors, but oh, Jude, I also need some activity panels on my role center, and I want those to come from 2 different queue tables, and we should display those as queue groups, and if I'm going to mimic a lot of other role centers, I want to see each of these processing states based on the enum value on this web order table. Well, the thing about it is that it could go read that enum. All of those queue tables then were created from those states in that enum. So in about 30, 40 seconds, because fun thing, I don't know if you've noticed this for those of you who have been exploring and trying this out, guess what? Hello, Tech Days. Hello, Tech Days. You can just tell it. So have fun with that. The other thing is I'm surprised, we're developers. We love to push buttons that we shouldn't push, right? I was surprised by the number of people who, opening this panel up, do ignore the bottom settings here and just leave it in ask mode. Switch over to agent mode and try out some stuff. And what you can do is you can add some different rules. So I want to add my README, because we all write beautiful READMEs that describe the whole repository, right? No? Oh, okay. Well, this is one of the reasons that my development team, I've been beating them over the head. If we have a README that describes all the things that are happening, which you guys can go see in the GitHub repo. This will describe all the things that we've just looked at today. This README can be used by the Copilot to process all this stuff, so that's really cool. And I believe some people were using Cursor, and that gave them the ability to give rules and stuff like that. I also did Copilot instructions. This will go to Copilot every time I submit a request. So I told it to do stuff like, include logging functionality and follow some coding practices. Just an idea, and maybe make sure the IDs are in the object range of the app JSON, maybe. So, and I want you to comment this real heavy. So there's a bunch of things you can do with this. I encourage you absolutely to clone this repo and learn. There's a bunch of different things I did in here. If you haven't watched Kamil Sacek's talk about Packet and NuGet and all that fun stuff, you'll notice that I also made use of Packet, which is the NuGet stuff. I don't download symbols in this repository. I don't hit download symbols. I actually run a command Packet NuGet and go get my symbols from the app source ecosystem out on Microsoft. So there's a bunch of stuff in here I would love for you guys to learn. I will probably write a couple more blog posts in the next couple weeks to highlight some of these different little bits and pieces. Explore in this and let me know how some of these patterns go. But there's absolutely a bunch of stuff I hate writing the code for. So one of my prompts was, I just want a progress dialog that gives me an estimated time of completion. Well, who here likes writing time calculation in AL? I saw someone blink for a second, and it was actually taking a photo. So, okay. But you can absolutely start to get a little more elaborate. Operator 3, this was the prompt I used. The only difference between my second and third operator was the dynamic scaling concept. Well, one prompt. The whole third demonstration from the second demonstration, those key differences, one prompt. I just wrote this. And if you look at the commits, I only started this repository Sunday. This commit I did yesterday. I gave it a whole bunch of stuff, and then I went and go watched a session, and I came back and reviewed it. That was it. It was coding while I was enjoying life. That sounds pretty nice. I like that a lot. But the good news is that there's that wonderful meme of AI coding will replace us when users can explain what they want. I can explain what I want real precisely with defaults and all that sort of stuff. But I did have some crazy things. Copilot is also great for troubleshooting. And my favorite example was when I was trying to build that little Gantt chart to display how the operations were working. There were some bugs in it. And at one point, I got a message I had never seen before that the date formula, 45,121 days, is too large. So I just plugged in, hey, I'm getting this error, fix it, and pasted the error message. And it was like, oh, okay, yeah, I found the issue. And then just for funsies, being an LLM, it threw at me, by the way, 445,121 days is over 23 years. Wow, all right. Glad you're excited about that. I'm a little surprised that the date formula can't handle 123 years in day form. So I did get a few different people also asking the question when I previewed this talk for people, how the heck was I doing this weird Gantt chart stuff? Anyone interested in learning a little bit more about that? Yeah. If you haven't played with it at all, I'm going to be doing a webinar a little later this month on Areopa. I hope people are well familiar. That is Areopa Academy. The link to that is in the slide deck, so you don't have to worry too much about finding it. But this wonderful channel, just like Central Q, I'm surprised by the number of people who maybe haven't heard about it. A lot of conference speakers, if they have a session that didn't get accepted, or it was a session they accepted and they want to share it because it wasn't recorded, will run those sessions on here. So this is a great place if you potentially want to become a speaker. You can do these webinars. They're just online webinars. But the mechanics of what we're doing here is a special JavaScript engine on top of Markdown. Hopefully everyone here has at least heard of Markdown. But this is a thing called Mermaid that is a Markdown style generator, and Copilots understand it. So when we were looking at our operation scale, we were looking at a whole bunch of, well, it's just text. And what's Copilot really good at? Text without understanding anything. Okay. Most people here are probably like me and looking at this going, I don't understand anything. Fair enough. There's a little generator that I made Copilot create for me that basically is just going out and generating the timings from our demo data. So underneath the hood in my application, when you go take a look at it, there are some log entries in here, and I was keeping track of what process it is, what stage it was in, how many things were operating, and all that fun stuff, which gave me the rich data I needed that this generator app could then loop through and figure out the time for each of those processes. And then in the end, what it will do is it will emit for me a lovely little text message that contains the Markdown, the Gantt, gives me a little bit of an explanation here at the beginning of that, and then we just generate that from buffer. And that's how I was getting, and of course Docker loves to fall asleep on us, and that just generates a text here. It's just text generation. We're good at text generation, right? Text builders are no big deal. So if you're looking for trying to diagnose stuff, and you've got log entries, try out that agentic Copilot thing and ask it to build you a Mermaid generator from your log entry. It'll read the log entry table, and you can say, I just want a Gantt. Okay. So hopefully that is something that you'll also take away as good value. And I ran the jobs a little bit faster than I expected to, but lots of people have planes to catch, so I don't feel too bad about being early. But that left us lots of times for questions, because I expect there to be a lot of them. Let's go.
So if it comes to posting, sales shipment, and invoicing, would you suggest the same method to do it?
The question, in case anyone didn't catch it, and I'm rephrasing so I can make sure I'm following, is when we're dealing with like sales order or warehouse posting operations, how do we deal with that, right?
Yeah, correct.
Yeah. The answer is I would treat each document as a discrete operation, because if a document from beginning to end posts successfully, great, you're fine. But if you can divide that up, warehousing in BC can certainly handle 30 warehouse people posting batches at the same time, and they're making improvements in the warehouse posting module. So why not batch that into 30 different job queues and run those at the same time? One thing I am experimenting with, and I would love feedback on this as well, is having the job queue kick off task schedulers. So there's one main dispatch queue entry, and it just chooses how many tasks to schedule. But in that scenario where you're doing the warehouse posting, at the start of the ship and invoice operation, and at the end, gate that transaction. Commit before, commit after. It's a nice discrete operation. And the smaller you can make those operations, the better. If there's data that you need to pull into that operation, try to get that onto the document during creation of that document. Then you don't have to go get the record during posting time. Any other questions? Or is everyone anxious to go home on this warm day?
So you mean you're splitting the post-shipment and the post-invoice, you're splitting that, or you still do post?
It would depend on how fault-tolerant the situation is. If the normal operation is when I hit post-shipment, that's okay, and we can stop there and leave it in that state, then that's an atomic unit of transaction. And so I would split those operations up. If they need to go together, like it only makes business sense that we would do those as two separate, as a same operation, ship and invoice, then leave them together, and that's together one discrete operation. So that was a big part of the thinking change to being able to spread the load out, is basically treating them as how atomic could I make each unit of work that I was doing. If that makes sense? So some of those processes, like the one in my demonstration, creating the sales order, transfer order, and purchase order, those all go together. If something goes wrong with order creation on the sales order side, I don't want to create a transfer or a purchase order. If something went wrong with the fulfillment, I couldn't purchase it, the item was purchase blocked, don't take the order. I could choose what level of discrete I wanted to deal with in that operational step. Or I might choose to say, okay, I really want the sales order to come in no matter what. I don't care if the fulfillment of that is a separate step. So you can make that business decision that in my scenario where maybe the purchase order can't get created because of an error, we still want the order to come through. So I would break apart the processing step to ingestion and reaction. And if reaction fails, that's okay, we've still taken in the order. But then you need to surface, how do I fix the situations that come up where the reaction hasn't been able to go through. So, yeah. Any further questions? Excellent. All right, let's see if we can do this.
You used the composed key for the list. Would the system ID also be an option to use that one?
Absolutely, yes. So in my, just to state in case it didn't come through, couldn't you just use the system ID? Absolutely, you can absolutely do that. And that's a really fast way to not care what the composition is. In my scenarios, sometimes a web order might come in 3 different parts. Because for whatever reason, a customer can come back to one of our web shops and say, I want to add an order line, basically. And so we'd end up with 3 order updates that we had to process for the same order. In our scenario, we want to process those 3 together. So that way everything goes. But if you have a nice, easy record set that there's a single record of operation, System ID is a great one because it's immutable. So, absolutely. All right. Ooh. I don't know that I'm brave enough to throw that far. I'm feeling pretty impressed with the fact that I'm 3 for 3.
So you made this because a customer had some demands that their solution wasn't running well, they weren't sure that it was running fast enough.
Yes.
And we had a little touch on posting, but how do you handle posting those orders for them? Because that has to be a major issue as well.
Mm-hmm. It absolutely is. We, in that customer environment, we had a separate set of job queues that were doing some of those posting operations. We found that the release cycle was where our customer was experiencing the most pain in the sequence of things because we're creating customers in our solution. And what they had done is they had gone out to AppSource and they installed credit checking and address verification apps. And now suddenly there's about 15 different API calls every time we create or update a customer. It got really bonkers in that order creation process, and that was where some of our slowdown was. I admit with the story on this one, we were at the 3,000 orders an hour. My testing in Sandbox, we got up to the point where our test batch, which we did was 20,000 orders, our test batch with 100 lines on each of the orders, we were doing 15,000 an hour. I didn't believe it, because it was Sandbox. And I don't know about you guys, but I honestly just didn't even expect BC to do 15,000 orders an hour on Sandbox. So I didn't believe it. I actually tested for 3 or 4 days because I was losing my mind testing all these things. But this is another major reason. If you are going to do some of these techniques, get familiar with the performance toolkit. I just did my own separate logging ecosystem in here, so that way I could do different timestamps. But the performance toolkit itself, you can see the scenarios and you can see how long different things are taking. You can get insight into how many operational read statements and all that sort of thing, where the slowdowns are. Most of my locking issues that I've had happen where my logging was too extensive. So you can see that in our operation here, we did even have one operation that took 20 seconds in the background because it was doing 14,000 updates. So get real familiar with the BC Performance Toolkit to help you prove your data scenarios. There are some built-in ones that you can make use of because, like I said, Microsoft loves to demo all sorts of things. There are already Performance Toolkit steps in here for posting sales orders with a certain number of lines. So if you're needing to test your environment because you've got a PTE or your app from AppSource, whatever have you, and you're not sure if things will go fast enough, you can absolutely try this routine. And you can also open up the Performance Toolkit and copy a lot of their logic and say, I want to do my own routines where I'm doing a bunch of posting operations. Our customer, the test scenario that I mimicked here, we just stopped at the release. We do a whole bunch of, we post the shipment separately, we post an invoice, we also do a payment queue up in an operation. So there's a lot more tables that we hit, and all the related ledgers that got updated as well. So it was pretty extensive. I was surprised at the speed we got. Like I said, extraordinary results. I wanted extraordinary proof. Okie dokie. Oh, we've got another question over that way, so let's go down this way. I was joking around with folks on LinkedIn. I always get nervous throwing and catching this. The only bone I've ever broken was from a padded sports ball.
Hi, Ivan here. Small disclaimer, this is no cloud question, no sure. AI agents. This is on-prem BC 14.
Ah, yes.
We have job queue issues. I'm pretty sure most of you had this, that a job queue stays in progress. Mm. You don't know, is it locked? Is it doing something? What is it? It just stays in progress. Mm-hmm. And yeah, and we all know if you do restart, it doesn't restart the process itself. Correct. Then you need to restart the entire service and so on. We have a lot of these. Do you have, I know this is a pretty old school question, but do you have any tip or experience on that?
Yes, my experience on that is that we moved our job queues in BC 14 on-prem to a separate service that we restarted all the damn time.
Exactly. As well.
Unfortunately. I did get a question in the Hoover app related to that with some of the on-prem that was asking the question of, is there a way to change the user that you're running the session as? And Microsoft is intentionally still not making that feasible and easy on purpose, because it has to do with audit traceability in some countries. Those operations that the job queue does has to be tied to some licensed person who said, I'm okay with this job queue running for me. Does it suck? Yes. Have we been brainstorming some alternate solutions? Yes. Are there also partner solutions that maybe can fix that? Also, maybe yes. One of the patterns that you can use for that is you can set up a job queue that schedules other job queues. And as long as your user says, I'm okay with this scheduler running, then it can look for the other job queues that you've ticked the box of, I want this to start, please, and it will start that job queue running. So you can get around that, but for the, sorry. I was wondering if we were going to fail. Sorry about that.
In your test scenarios here, this is a pretty isolated test with basically only your one process interacting with both items, sales, and warehouse.
Yep.
So my big question would be, what's your experience with tests that actually start with very different start points when you have like several marketplaces that want to do this with their own custom things, and you also have a warehouse that has their own warehouse activities and they're also working, but decoupled from your actual test case here, and basically just putting volume in the system while you want to try and see how yours does.
Yeah. There's a couple different parts to that question that I'm hearing. One is, if you're starting at different points in the process, like what kind of scenarios can you do? In the performance toolkit, you can set up lots of different code units to run. So you could create test scenarios that are creating orders. You can create scenarios that are posting. You can create scenarios that are warehouse workers updating shipments. You can create all these different scenarios and set them up to run as numbers of sessions. And those will all run simultaneously, I believe, if I recall correctly. So you can simulate the environment. The goal out of a toolkit like the performance toolkit is you should be able to simulate normal load. And that means that you have CFOs and sales order people, warehouse people doing all these different operations. If you're talking about the testability when you're dealing with external systems, there things get a lot more complicated because then you're potentially dealing with external systems that are sending data in or you're reaching data out. It gets a little harder. And there in that space, I do, for our customers, we do a lot more of Vyska style mocking, where I have implementations that simulate fast warehouses, that simulate slow warehouses. I think one of my favorite logistics partners that we work with, their API can only take one order at a time. Even at 150 milliseconds per order, that's awful. So thankfully, they've updated and they're now taking batches of 20. That's a little better. High volume. So when you're dealing with the testability of trying to test this parallel mode thinking, you're going to have to think about when you're dealing with external systems, you're going to have to do some mocking scenarios. So you might have to create a simulation code unit that calls into your own BC API to simulate the warehouse going, we've just shipped something and we want to let you know about the 500 serial numbers you just shipped. That's one of my favorite test scenarios if you want to really churn locking, is turn on serial numbers for items, because then you get one item ledger entry for every single quantity. It's nightmare mode for locking. So do big orders of like 500 batches with serial numbers and you'll really see the performance of that. So to simulate the warehouse sending in operations, create a mock code unit that puts data in the same place that an API call would. Do those two different parts of answers speak to what you meant? Okay.
Thank you very much.
Absolutely. Hopefully I'm not going to bean anyone else with a microphone. Okay, well, then I think that's that, and we will let everyone get on to their airports. And, well, we've got the closing session. Hopefully lots of people are going to enjoy that. and hope everyone has safe travels. This code is all up on the GitHub for me. It was the link in the QR, but you also have the slide deck, and I'll contact Luke to make sure the GitHub link is in the video description on YouTube. I hope everyone here knows that all these are going to be up on YouTube. So, hope everyone's had a phenomenal Tech Days, and sorry for the Copilot fake out.